So this one says how large of an impulse would be required to get a 1.41 times 10 to the 7 kilogram train moving 15 meters per second when starting from rest. And if it says if this impulse is applied by 3 locomotives, each pulling with a force of 811,000 newtons, how long does it take to accelerate the car from a stop to 15 meters per second? So this is two different questions, so we have to do the math 2 different times. We have to do 2 different problems. We can still start by writing what we know. We know that our mass is equal to 1.41 times 10 to the 7 kilograms. And if it's starting from rest, our velocity 1 equals 0, which means our first momentum also equals 0. And in both cases, we're trying to get to 15 meters per second. So our second momentum is 15 times this, times our mass. So we get 2.12 times 10 to the 8th kilograms times meters per second. And now we're going to look at the problems separately. In the first one, we're asked how large of an impulse. Now, a lot of you are going to say, I don't know what impulse means. In the impulse momentum equation, the impulse is what causes the change in momentum. So an impulse can be calculated by F delta T, or you can say the impulse is equal to the change in momentum. So our impulse is equal to P2 minus P1. So impulse is 10 to the 8th kilogram times meters per second minus 0. So here's our impulse. It's how much the momentum has to change. And we can get to this in 2 ways. Remember that this is equal to F delta T. And so we can have a very large force over a small time, or we can have a smaller force over a larger time. And this we see in our everyday life. Think about when you're driving your car. If you are going 35 miles per hour and you want to go 55 miles per hour, you have 2 choices. You can slam on the gas and speed up very shortly in a very quick amount of time, and you can hear the engine usually rev up and apply a lot more force. Or you can press the pedal more gently and speed up in a longer period of time, but you won't hear your engine rev and you won't use as much gasoline. So you see this impulse momentum equation in your life a lot. Pretty much anytime you're moving, really. So we've answered our first question. This is the amount of impulse. So the second question asks about this part of it. If this is the impulse, and we're given a force, how long is the time? So our force, each locomotive applies 81,000 or 811,000. But there are 3 locomotives. So the total force applied is the 811 times 3. So we get 2,433,000 newtons. So we can say that delta T is equal to our impulse divided by arc force. If you're curious about how this ends up being seconds, remember that a Newton is a kilogram 10 meters per second squared. So all that cancels out, and the square cancels out. And we see that it takes 87.1 seconds.